Hello everybody, I will continue the classification of polymers and I will start with the classifications based on mode of polymerization. In fact, in this classification we have two big axes. We have the chain growth polymerization and the step growth polymerization. In the chain growth polymerization we have the monomers that have a double bond or a triple bond. So these monomers can be added to each others without elimination of any byproduct. So here we have addition of monomers. So as the monomers take the hands of each others. So here we talk about chain growth polymerization or addition polymerization. But for the condensation polymerization here, we talk about organic reactions. So we should have at least two functional groups that can react to each others. And thus we have, as a result of this addition, elimination of small molecules, H2O, H2S, etc. So here we talk about step growth polymerization. We have organic reaction and we have elimination of small molecules. Then we have the classifications based on molecular forces. According to the molecular forces, polymers can be divided into four groups: elastomers, fibers, thermoplastics, and thermosets. First, what are elastomers? When the polymer chains are connected to each other by weak intermolecular forces, so we talk about elastomer polymers. Example of such polymers type is the natural rubber. If you remember, that was discovered and studied by Schrödinger, and it's of isoprene repeated monomer units. The rubber is made, in fact, of long polymer chains that can move in independent relative way to each other, which result in change of shape. So they can be shaped under forces. As the natural rubber suffer from an elastic deformation, vulcanization is done to add few crosslinks. So here, if we look on the natural rubber, we can find long polymer chains connected with few crosslinks. So it can be stretched, but the problem, it's stretched in an elastic way, so can't go back to the original form and size. So that's why we need to make vulcanization. So the vulcanization is the addition of sulfur bridges between the rubber polymer chains, helping the natural rubber to retract to original shape after applying a force on it. So we obtain a semi-synthetic polymer, which could be used in many applications such as tires, shoes, etc. The second category, if the polymer chains are held together by strong intermolecular forces, so we talk here about fibers, fiber polymers. In the fiber polymers, the existence of these strong forces lead the polymers to pack together. If they pack together, so we obtain a solid, and thus we have crystalline nature. We'll talk about it later. So as a result, these fiber polymers possess high tensile strength and high modulus, and these are of the specific properties of polymers, and I will talk about it while explaining the mechanical properties of polymers later. and they show sharp melting points. Example of such fiber polymers is the nylon. Nylon, in fact, nylon is discovered in 1935, and its name, it's discovered in two different places. In fact, NY, it's abbreviation for New York, where it's discovered, this nylon. Also in London, so we have its name from New York and London. So this nylon is polyamide chains. We have the amide function. So we have the linear polymer chains, which are connected to each other by hydrogen bonds. So they can pack together, giving the fibers the solid nature or crystalline nature. So science to extrude nylon into fibers, they got inspired from the spider spinneret, and they produce a polymer spinneret, which is a device used to extrude polymers into fibers by analogy with a spider. How to do this? In fact, science take the viscous polymer، يعني بناخد النايلون وبيكون مسيلينه. Then we exit this polymer via the spinneret into air or liquid to have inversion of phase, which allows the polymer to solidify. Thus, each polymer chain tend to align in fiber. This process, in fact, is similar to the formation or to the production of cotton candy. إذا شي مرة شفتوا اللي بيعمل غزل البنات بيكون عنده سكر سايل وبظهره بيصير في عندي air stream وبيصير في عندي formation of the cotton candy. Third, we have the thermoplastics. In this category, the strength of intermolecular forces is intermediate between elastomers and fibers. What is specific of this polymer category is the absence of cross-links between polymer chains. In fact, the polymer chains are connected to each other with extremely weak bonds. Under heating or while heating these thermoplastics polymers, these weak bonds are broken. So the polymer chains can move easily. Thus, these thermoplastics can be molded or reshaped by heatings, giving these polymers their name, thermoheat, and plastic deform. These polymers are used in a wide range of applications, as they can be formed and reformed in so many shapes. Examples of these polymers, we have the polyethylene, the polystyrene, we have the polyurethane, which is used to form artificial hearts. We have also the polyglycolic acid, which is used to make biodegradable suitors. So these thermoplastics are extremely used. At the end, in this category, we have the thermosets. Thermosets or thermosettings polymers are usually made from low molecular mass chains. The connection between chains is very strong. We have an extensive cross links between the different polymer chains. Thus, we have a formation of 3D networks. And these thermosets or thermosettings polymers, as a result, cannot be reshaped by heating. So we have their name, it's thermo for heat and set for permanent. So these polymers cannot be reshaped by heating. For example, they are used in many applications, as in automobiles and constructions, also to make toys. For example, إذا إذا قاعدين على كرسي بلاستيك وصرتوا تمدحوا فيها وترجعوا بتنطعج شوي. إذا رجعنا سخناها فينا نرجع نعمل لها ريشيبينج لأنه من ترموبلاستيك. بس إذا لعبة الولد انكسرت ما فينا، بالأحرى ما بتنطعج دغري، بتنكسر لأنه ترموسات. ما فينا نرجع نسخنهم ونحطهم على بعضهم ويلزقوا لأنه thermoset polymers, but أكيد we have specific polymer glue to fix them. Examples of thermosets polymer, we have the bakelite, we have the melamine, the polyvinyl chloride also with high cross links هو بيصير thermoset وبنستخدمه for example to make sinks. يعني بس بدهم يعملوا المجالة من هايلي كروس لينكد بوليفينيل كلورايد، بده ياخدوا الشيب تبع المجلة ودغري يصبوا البوليمر على هذا الشيب، لأنه وانس سقع خلاص ما بيقدروا يرجعوا يعملوا له reshaping. So here if I consider the bakelite for example as example of thermosets, the bakelite is considered as first synthetic polymer. It's a thermosetting phenol formaldehyde resin. This polymers is widely used. For example, in 1931, Ericsson make first bakelite telephone. We have the bakelite letter, the one that we used to open the letter from around 1920. وإذا شي تيتا من تيتا عندكم عندها بعد من هيدا الراديو القديم اللي كانت تسميه عظم، هو باكليت، هو very important هلا وبيبيعوه كأنتيك يعني ب$5000 $6000. so ثروة. Very interesting. If we want to compare or make comparison between thermosets and thermoplastics, in fact the thermoplastics we have weak interactions between the polymer chains. In thermosettings we have lots of cross links between the polymer chains. The thermoplastics are obtained by addition polymerization, while the thermosettings polymers are obtained by condensation polymerization. For the thermoplastics we have linear polymers. Here for the thermosettings we have 3D network because of the high number of cross links between the polymer chains. The thermoplastics are soft. They can be shaped and reshaped under heating. The thermoset polymers are hard and strong and cannot be reshaped. The thermoplastics could be soluble in organic solvent, but the thermoset no. So that's why إذا عملنا المجال من highly cross-linked polyvinyl chloride, هودي الsinks resist to organic products and to heat, etc. Now we'll talk about another classification of polymers, which is classifications based on kind of monomers. In this category, if we have one monomer kind, we can talk about homopolymer, two kinds, copolymers, and three kinds, terpolymers, etc. In the copolymers, we have also different types. For example, once I said copolymers, so I have two kinds of monomers. Here I will consider the monomer A and the second monomer is B. How the monomers A and B are organized in the polymer chains. Thus we have different copolymer types. For example, we have the random copolymer where the A and B are distributed randomly in the polymer chains. We have also alternating copolymers. We have AB, so the monomers A and B are distributed in alternating way in the polymer chain. We have block copolymer, so we have the homopolymer A and the homopolymer B, which are connected together as block of A polymer and another block of B polymer. We have also the graft copolymer. The graft copolymer, we have the polymer chain of the first monomer, for example, here the A, and then we have the polymer B, which is connected over the backbone polymer chain. Here we don't talk about branched polymers, because the branches here are of another nature, are of another monomer nature. So here we have graft copolymer. If you remember, I talked before about branched polymers. If the monomer A, we have the backbone monomer A, and the branches are also of the same monomer A, we talk here about just branched polymers. But if we have a backbone chain of a specific monomer and the branches are of another monomer, here we talk about graft copolymer. And if the number of branches is high, so we can form, or we can obtain what we name star copolymer. So here inside I have the core, for example, of the polymer chains of the monomer A, and the grafted here over or from this core of monomer A's of monomers A are of monomer B. Now also we'll talk about another kind of classification of polymers, which is based on structures. The structure of a polymer is defined in terms of crystallinity. This might also be as a degree of order or regularity, or how the molecules are packed together. So if we have a well-ordered polymer, is considered crystalline. The opposite is anamorphous. In fact, in crystalline, we have the polymer chain, as I said for the nylon, for examples, where the chains are linear, they can become close to each other and connect to each other via bonds. And as they can pack together in ordered way, they can form solid structure of crystalline. For the amorphous, the polymer chains, there's no order how they are. The chains here, the chains, there's no cross links between. Here they are tangled, just مثل كأنهم مربوطين ببعضهم ربط مثل السباجيتي إذا بدنا. سو إذا فينا نتخيل الكريستالين هي السباجيتي اللي كنا حاطينهم لما كانوا بالكيس back together. بعدين الامورفوس نتخيلهم once طبخناهم هذا السباجيتي و they are tangled together. For the semi-crystalline is mixture of crystalline or amorphous. So we have certain percentage of crystalline organized chains here in the polymer, in the whole polymer, and we have amorphous parts. And concerning the properties, so as it's semi-crystalline, so we have mixture of the properties of the crystalline and of the amorphous polymer, and these properties are dependent on the percentage of the crystalline part and of the amorphous part. The last category here, it's classification based on applications. This classification would not be complete because of many factors. First, the extreme variability of polymer properties and the endless utilization of polymers. So this classification is hard to be done, but however, the scientists tried to identify three main categories of polymers as a function of the application. We have the commodity polymers, the specialty polymers, and the technical polymers. If we start by the commodity polymers are the most used polymers that we are facing everywhere around us in our everyday life. And in fact, these polymers usually are produced from a few simple starting compounds, and thus they are not expensive. As examples of this category, we have the polyethylene, polystyrene, polyvinyl chloride, polypropylene, and polyethylene terephthalate. These polymers you should know by heart. يعني whole البوليمرز, whole الcommodity plastics, you should know their name, their abbreviations, their structures, and some of their applications. whole لازم تعرفوهم. In parallel to commodities polymers, we have these specialty polymers and functional polymers. These polymers are characterized by specific properties, giving them the ability to be used for particular applications. These kind of polymers can be produced by two ways. First, we can take simple and non-monomer. We can assemble them into complicated architecture, and then we can make modification to include specific functional groups to make this polymer able to be used for specific applications. Or the second way is to synthesize new complicated starting monomers where the future functions are already implanted inside the monomer units before their assembly into polymers. These polymers are expensive, sometimes can be more expensive than gold or diamonds. Example of such polymers are conducting polymers, which is widely used in biomedical applications. And these, for example, these conducting polymers compared with traditional metal or semiconductors materials, these functional conducting polymers are more biocompatible, so they are better to be used. Also, another examples, we have photoactive polymers, we have thermostable polymers, we have adhesives. We have also, as example of synthetic adhesives, so we have the epoxy. إذا سامعين فيهم هول الإبوكسي بيستخدموهم as adhesives or as glue ليصلحوا فيهم خزانات البلاستيك, so they put it محل ما منقور الخزان for example بيحطوا له adhesive epoxy. Also, we have as example of functional polymers or specialty polymers, we have these smart windows. الشبابيك اللي منتبهين لها اللي بيسموهم السمارت ويندوز, اللي هن فيهم specific functional groups بيتأثروا بالحرارة وبيتأثروا بأشعة الشمس. so منتبهين أكيد في هودي البيلدينجز اللي بيبقوا كلهم إزاز, بيبقى مثل الميرور بالنهار وبالليل بنرجع بنقشع through it. هول smart windows فيهم specific functional polymers having specific properties خلينا نقدر نستخدمهم for such application. The last one inside this category is the technical polymers, or also called engineering plastics. These kind of polymers, they have specific mechanical properties, and they are used for sometimes to replace traditional materials as metals, ceramics, etc. in many applications. For example, of this category, we have the polyamide, polyacetals, which are used in gears and pump impellers, etc. حاجة صغيرة بس بليز, إذا بتنتبهوا للبوليمر classifications بالسلايدز اللي كنت حطيتكم هون قبل, here I added a new category, classification based on structures. Okay, that's all for now. See you next time.